Hi everyone, this video is for section 8.3 in your textbook on converting angles from degrees into radians in terms of pi and going back in the other direction from radians in terms of pi back into degrees. First of all, I want to talk about reducing fractions because that's what you need to do to make these types of conversions. So this will take you back to the days when you were reducing fractions back in elementary school, but just as a reminder, here's how this is done. If I have a fraction, 9/12, and I want to reduce this to its lowest form. So the idea is we're looking for a number that goes into 9 and 12, and it is the greatest number that goes into 9 and 12. So we call this the greatest common factor. So if you want to think about that as, well, what are the factors of 9? Integer factors. What numbers multiply to make 9? Well, 1 times 9. So 1 and 9 are factors of 9, and 3 and 3. So these are the factors of 9. We do the same thing for 12. What integers multiply to make 12? Well, we've got a 1 and 12, 2 and 6, 3 and 4. And there aren't any other integer factors of 12. Now we're looking for the greatest common factor. So you might have noticed, yeah, we've got some common factors, 1, 3, 1, and 3. And we are interested in the greatest of those two. That's the 3. So that if 9 and 12 are both divided by 3, we haven't changed the value of this fraction at all, we've just changed the way it looks. So here's how it looks. 9 over 12. Let's divide each of those numbers by 3. And we're not changing the value of this fraction because we're dividing by 3 over 3, which is like dividing by 1, which is not changing anything. So we look across the numerator. 9 divided by 3 is 3. And 12 divided by 3 is 4. So these two fractions are equal. We can even see this visually if we look at a wheel. I have one wheel, or a pizza, or pie, or something, divided into 12 equal factors. And we want to maybe represent 9/12. Okay, there are my 9/12. And now over here I'm going to represent the same fraction, 3/4. And what you probably, and I hope you really notice this, is that these are equal to each other. The same amount of these circles is being shaded. It's just a different size sectioning that's been happening here. Okay, this can be done with your calculator. Have a look at your calculator. You probably have a fraction key that looks like this. A, B over C. It might be just B over C or A over B, but make sure you look at your calculator. We've used this a bit in class, but if you haven't looked yet, look for a fraction key. Now I'd like you to enter 9 and hit your fraction key, A, B over C, and enter 12. Do not hit the equals just yet. Have a look at your screen and notice how your calculator is displaying this fraction, 9 over 12. Okay, it might look something like this, 9, and have a little symbol in between, just to show the difference between the numerator and the denominator. Okay, now hit equals, and your fraction will be reduced to 1 over 4. Depending on the calculator, and if you have a right view, it's displaying as a fraction that way. Okay? So this is how you can reduce fractions with your calculator. And this is going to be necessary when we are working in this particular unit. So let's go there and have a look at that. Radians in terms of pi. So far we've been multiplying angles in degrees by pi over 180. Well, to change them to radians in terms of pi, we're going to be doing the same, except not hitting the pi button. What you want to do is take your angle in degrees, multiply by pi over 180, because we still are converting to radians, but just reduce the fraction. Leave the pi in that expression. So the fraction 30 over 180, this 30 is over 1 over 180, reduces to 1 over 6. So this is like a 1 pi over 6, or pi over 6, or even 1/6 times pi. Different ways to look at it. So here's something you can do. Following the same pattern, try to change 45 degrees into radians in terms of pi. Pause the video and jot this down on a piece of paper. Okay, so now that you've had a chance to try it, this is what comes out. You might have written down 1 pi over 4, and that's fine, or 1/4 times pi, that's also fine. Just to give you an idea, pi over 4 radians is approximately 0.7854 radians if you multiply it all out the way we've done in our other lessons. And these would be equal. This one's in terms of pi, and this was in decimal form that's been rounded. These are still both radian angles that are equal to each other. Okay, here's a little more practice. Pause the video and try these two. And here are the results if you want to have a look at how they can be represented. So you might have 2 times pi both in the numerator all over 3. That's the same as 2/3 times pi out to the side. You're just going to see people doing this it's just a matter of style really, whether a person writes it one way or the other, but they are the same thing. Okay? Now we also might need to go from radians in terms of pi back to degrees. When we're going from radians to degrees, you multiply by 180 over pi. So here's a fraction, 3 pi over 10, which is an angle in radians in terms of pi, multiplied by 180 over pi, which is the conversion factor to put it back into degrees. And so multiplying fractions, remember, numerator times numerator, denominator times denominator. If you'd like to do some canceling first, you will notice that the pi's cancel out, so they're not even an issue in this when we're going in this direction anymore. And you maybe canceled 180 and 10. They're both divisible by 10, which becomes 18 over 1. And then we multiply 3 times 18, which is 54. 1 times 1, which is 1. 54 over 1 is 54. Okay, pause the video and try to do these two. And here are the results. Pi's cancel again. And that's it. So I'd like you to practice some of those. You'll have one question on your assignment, possibly a question on your quiz on that particular topic, but that's a lesson on converting to radians in terms of pi and from them back into degrees. Thanks for watching.